Hi everyone, this is Mr. Gun from Team Gun Math Learning Center. So this is the second question of the weekly practice. This question is on graphing techniques. Sorry, there's a typo. It's actually supposed to be from VJC, the prelim question from VJC of the year 2013, paper 2, question 2, not paper 1, question 10. All right. So let's just dive into this question here and just see how we can solve this properly. I think for the first part A, part 1 should be quite straightforward because you're asked to find ABC, right? ABC means in this case is basically just the unknowns in the expression here, and you're given that it passes through this point that has a minimum point here. Okay, so if you have three unknowns and you want to solve it, so you need to have three equations to solve the simultaneous equation, right? In this case, I think sometimes students forget to sub the point here. So you have you can sub x equals to 3 and y equals to 23 over 2 inside the equation. You can sub x equals to 2 because these are points and y equals to 10 into the equation. And you could also sub dy dx equals to 0 when x equals to 2. Okay, so there are three equations here. So I'm just going to do this quickly. So the first part here, when x equals to 3, y equals to 2 third 2, what you get is 2 third 2 equals 23 over 2 is 3 squared. So I'm just going to sub this equal inside here, plus b times x 3 plus c over 3 over 3 minus 1. So this is 2. So this will be 9a plus 3b plus c equals 23 because the denominator could be cancelled on this both end. Right, then after that you you sub the other value, which is x equals to 2 and y equals to 10. All right, so this case here I got 10 equals to a 2 squared plus b 2 plus c 2 minus 1. So this is also pretty okay. 4a plus 2b plus c equals to 10. Right, so I've got the other equation here. Then since so now we need to dy dx this expression. So dy dx y equals to ax squared plus bx plus c over x minus 1, right? Am I right? X minus 1. So if I were to dy dx this, I will know that dy dx is equals to x minus 1 square, x minus 1 2xa plus b minus v du dx u dv dx. Okay, so this is all right. So when x equals to 2 dy dx is 0. So x equals to 2 dy dx is 0. Now dy dx is 0 means that the what do you call it, the numerator is 0. You don't need to worry about the denominator because the denominator will never be 0, and this is 0, right? This is 0. Just the numerator will be 0. So here what we get is 2, substitute in, I will get 4a plus b minus 4a plus 2b plus c equals to 0. Okay, so the last expression I could actually what do you call it, reduce it to, this is minus b minus c. So minus c minus b equals 0. All right, so we have got 1, 2 and 3. If you were to solve it using GC, so just use GC. You do not need to solve it because typically there's no marks for simultaneous equation, right? So you just use GC and you will solve these three unknowns there. Okay, so solving 1, 2 and 3 lah. There you go. So that's okay. I think part 1 is all right. Now let's look at part 2. Part 2 is sketch C and find the so this is also just basically what you need to do is given the coordinates or anything blah yada yada. So what you need to know is this is the minimum point. You already found one. You could actually just use the GC and sketch it out. And also find the asymptote means you need to do a long division, right? Because this is a rational function here. So what we're going to do is I'm just going to write the expression here, which is 3x squared minus 2x plus 2 over x minus 1. So in order for me to find the oblique asymptote, I need to do a long division. So in this case here, I'm just going to do it quick. This is x minus 1, 3x squared minus 2x plus 1, 2, 3x squared minus 3x. Then this will be x plus 2 plus 1, x minus 1, then this is 3, right? So y is equals to 3x plus 1 plus 3x minus 1. There you go. So hence, the oblique asymptote will just be y equals to 3x plus 1, and the vertical asymptote will just be x equals to 1. So if you were to sketch this using your GC, you will see something like that. So I'll typically will ask my student to just sketch the what do you call it, the expression properly, right? So here, sketch out the oblique asymptote, because you never know whether you long divided it properly in the exam. So just put the oblique asymptote in the equation, and then after that you just do the use the original equation. Just use the original equation here, which is 3x squared minus 2x plus 2 over x minus 1. Okay, so graph it, you will get the expression here like that. So you know that on top it will pass. So you know, if you look at this expression here, it will go through there's a minimum point on top. I'm not sure whether you need to just zoom it out to see the minimum point on top, right? Then you can zoom out. So I'm just going to zoom it out. Zoom it out. It looks very yeah, I could just find the mean point and max point there, right? But if you want to change the window settings, you could just put minus 10 to 10 so that you won't be so squished in this case here. There you go. All right. Yeah, so I got this expression here. So now what I'm gonna do is I'm just going to try and sketch this out. I know that my oblique asymptote is 3x plus 1. So 3x plus 1 is just a straight line. It's not very difficult to draw this out. So I know that I'm just going to use another color. So this is my 1, and 3x plus 1 probably is like that. So I let my 1 be about here. This will be my minus 3. This is negative 1/3, right? And this will be 3. No, that was 1. All right, there you go. Rise is 1. Yeah, 0 minus 1. Yeah, good. Then I have got my vertical asymptote, which is about here. So here, try to draw the scale. So this is 1/3. So this is 3 times of it. So I just roughly just roughly draw it out. So here will be my x equals to 1. I realize that the x equals to 1 is my the purple color line supposed to be dotted, right? So because I do not have ruler, so please dot it out. So this is 0, and once I get this ready, I'm just gonna put the minimum. 210. 210 is my minimum point. So I know that 210 is about here. So this will be my graph here. Sorry, I'm eating 210. And then the other point would be using GC. You should know how to find this. Is 0 minus 2, negative 2 here. This is the graph here, right? So this is 0, negative 2. So here 0, negative 2. Okay. Just label the coordinates, because they ask you to label the coordinates of any. So you need to label in terms of coordinates, right? Not just the intercepts. Okay, great. There you go. You get the graph like that. I'm sorry I ate into the space on top. Should have just put it down a bit. Move it down a bit. Maybe I would move it down. Let me see whether if I can move it down. Okay, now I'll just leave it like that. Okay, now let's look at the next part here. So we know that this equation is y equals to 3x plus 1. This is x equals to 1. Okay, now let's look at the next part, which is an interesting bit. Find the set of m minus k with the equation where this curve here does not intersect c. So first of all, you must understand what is this curve here, right? So let me write this curve down on the side. This is part 3. This curve here is x squared kx squared minus off the bat, I know that this is a hyperbola, because it couldn't be a circle because the coefficient of x squared and y squared is not the same, and this is a minus. The sign of the x squared and y squared is different, so this has to be a hyperbola. But whether it's like that or like that, right? So you just key in your calculator. If you draw it, it's actually the side curve, right? So the center would be 0 and 1, 0 and 1, and first of all, because at a glance you may not know what is m over k, right? M over k. So if you do not know what I would suggest you to do is just find, like, you know, the equation of asymptotes and any other things that you could find. So the oblique asymptote would be just x square k square. This equals to this, right? So that's your oblique asymptote. So this is your oblique asymptote. When x goes to infinity, these two equations would be roughly the same. So if you were to make y the subject, you realize that you get m over k x plus minus, right? Because you open square root, y equals to m over, now m over k, then it becomes clear, because now this is your m over k is actually just the gradient of the asymptote, right? And the center of this oblique asymptote is just like it passes through this point here, 1, 1. So what you're gonna do is, you know that this curve here, this oblique asymptote will look like that, right? It will pass by here, and the question now is, what should your m over k be so that it doesn't intersect it twice, right? And m over k are positive constants, so they never be m over k positive, so this has to be bigger than 0, right? That will be bigger than 0. So that is the question here, positive constant, and how basically this positive constant, right? So to visualize this, you know that this equal line here, this is actually m over k equals to 3, right? This is m over k equals to 3. So you can't, anything more than 3 m over k, if the gradient of this asymptote here, anything more than that, you would actually intersect the curve at twice, right? So that's the thing. So in observation, what you should know, okay, to visualize this, I think I'll just bring up the Desmos app so that you could see this right clearly. Let me bring it out. So this case here, Desmos app is the way to go. Equals to 3x squared minus 2x plus 2 divided by, okay, then you have got, let me switch off the grid, then you have got y 3x and x equals to 1, that's your asymptote, and then you have got y x squared the gradient, let my m over k be y squared equals to, let's say this is a square x squared minus 1. Okay, so just to illustrate, so what I'll do is I'll just label the this is a curve, the red color, now the purple color is a curve. So this over here, what I'm gonna do, I'm gonna change this value here to, there you go. Okay, let's say it's like that. Okay, this is a gradient of the so let me minus k squared plus 1. Come on, m squared. Okay, roughly. Okay, plus 1. Okay, it will look something like that, right? It's not exactly this, but I'll just use this anyway. So we know that the red color is the hyperbola, So any k value, now k, this a is actually my k over m. So anything that is above 3, it will cut the curve twice, right? So it will cut the curve twice. So you see that? So when this is 3, the equal to 3, then it will not cut. So anything more than that. So this case here, the question they're asking is basically, what should your k be so that it doesn't intersect? So obviously, if this is m, this is gradient here, this a, the gradient here is 3, right? So you have to be less than this lah. So in other words, by observation, you know that m over k has to be bigger than 0 but lesser equals to 3. So that's your answer. Okay. So in the solution set, it will look like that, comma, curly bracket. Right? That is part 3. Any question, comments, please do ask me. Okay. Part 4 is all right. Part 4, I think just need to use the what do you call it, the discriminant. So in the case where a minus 1, b, find the side over c where it has no stationary point. So we are looking at dy dx. We do not want to have dy dx to not equal to 0. So it means b squared minus 4ac, right, has to be less than 0, because the numerator of the derivative is actually what do you call it, it's a quadratic, so we could just use that. So in other words, right, dy dx, we're looking at when c equals to, when a equals to minus 1, b equals to minus 1, where the case where c equals to, yeah, my dy dx, I found my dy dx just now, which is this. Okay, I'll just write this down. I think it's easier just to differentiate again. C over x minus 1. Okay, so here what I'm going to do is dy dx it x minus 1 square x minus 1 2x minus 1. There's a constant, so I'll just leave it v du u dv dx, right? So 1. So this is it. So in other words, when dy dx equals to 0, the top we just expand. You know that minus x squared is plus 2x squared. So it will reduce to this form, right? The numerator will reduce to this form. So for no stationary point, you know that b squared minus 4ac has to be less than 0. Okay, that you cannot have any stationary point. So from here, the discriminant we know that is 2 squared minus 4 minus 1 minus c less than 0. So this case here, what you get is actually just c bigger than 2, right? So that is the answer, c bigger than 2. But c cannot equal to 2. Actually, the answer I think is wrong, because it states that c cannot be 2. Okay, so that's the answer there. Okay, so that's how you do this question properly, proficiently. So any question, comments, please feel free to leave under the comment section below. Or if you want to learn anything about my tuition class, please visit my website at www.teamgunmath.edu.ig. So yeah, thank you.